concept, which is الابstract class والinterfaces. Okay? So we'll talk about the abstract class and the interfaces. Those are the topics that we're going to cover. We will talk about how we design an abstract class, what does it mean, why we need it, same with the interface, and how they are different and similar. And we will talk about a specific or built-in interface called comparable, which is a Java interface, and how we can use it. Okay. I believe is the best way to explain the concept. First, let's say an example, and then I'll move to the literatures. Okay. So let's move to the example on slide 7. If we go on slide 7, we'll see this the example which is similar to what we already saw on a meeting 5. If you remember in a meeting 5, we already create a superclass and subclass, where a superclass was a geometrics and a subclass was a circle and a rectangle. Okay, so I'll remind you what we had in a meeting 5, and I'll back to this meeting. So I need you to try to really notice what the difference, so then we can understand what's the abstract class and why we need it. So this is what we had during meeting 5. So we have a superclass called simple geometrics object, and then we have subclass or child circle rectangle. What I need you to take a look here, you see a circle or rectangle, both of them has an area and parameters methods, both of them, but not the superclass. Okay, so this is the first difference we had. However, in our example here, when we were going to talk about an abstract class, a geometrics object class, which is a superclass here, it's abstract class. What does that mean? It's going to have two constructors, but those constructors have a modifier about the modifier called protected modifier. And if you remember, the protected modifier can access from the same class, from the class in the same package, and from a subclass, but not from a class on another package. Okay? And you see here, we move a get area and a get parameter from a subclass into superclass in this abstract example. In the previous one, we had them repeated in the previous and the subclass, circle or rectangle. Now we moved it here as an abstract method. And this is what we're going to take a look, and we need to understand it, okay? So let's move to NetBeans and see the example. I'll explain the stuff on the code, and then we will back to the presentation. Looks like it's a little slow there. Do you see NetBeans or PowerPoint, guys? Okay, just give me a second. I'll change the connection. Hopefully this is much better. Okay, so example what we're going to see here, we're going to build uh, we're going to build superclass which is still called the geometric object, but this time is going to be abstract. Why are we going to create abstract? Well, we already did the same example in a meeting 5. So why we need abstract? Logically, let's think logically, guys, okay? If you're having a subclass, if you have a shape called circle, you can have a shape called rectangle, you can have a shape called triangle, for example. But it's meaningless to create an object that's just call it a shape. You don't know what is that shape. It has a color and it's full, so then what? If you create an object from a geometric object, that means you don't know what is that shape. So for that reason, the abstract class is coming to solve this problem. Sometimes you need to have a parent or a superclass that has a common behavior, but in the same time, you don't need to create an object from that class because it's meaningless. Okay, so for example, if you're having a class called animal, and then subclass is, as we're going to see, for example, tiger, chicken, whatever. Is there any meaning to create an object called animal? No, because you don't know what is the type of the animal. So that's why for this type of concept, okay, so for this type of problems, we get to use abstract class. So you have a superclass, but at the same time, you cannot create an object. You cannot create an instance from type geometric object. And for this reason, you see here, this is the constructor. We use a modifier called protected here. That's because it can be accessed from a subclass, which is a child, like for example, a circle or a rectangle, but it cannot be used from itself because it's an abstract class. So this is the superclass geometric object, good? And I have a constructor. Let's back to the test. I have now 4 classes. The superclass, a geometric object, I have a circle, and I have a rectangle. You remember? Back to our presentation, you see here, I have a superclass and I have a circle as a child, I have a rectangle. And I have a class called test geometric object. This one, which is, it has a main method. So inside the main methods, let's assume I would like to create geometric object. This is the type of object, and I call it test object equal new, and then geometric object. Okay, you see what I get here? I get an error. Why? What's the error said here? Geometric object is abstract, cannot be nested. Okay? Yes, I write in NetBeans now. So I'm explaining the example. Yes, I am writing on NetBeans. So I'm going to explain the example and I back to the presentation. Okay? So I'll explain all the concept here, guys. So we get it in practical first. So you see here, if I would like to create an object or an instance from type a geometric object, I get an error. Although it's a class, but because the geometric object is an abstract, which is mean you cannot create object or instance from it. You can use it as a data type. You see here in the example, we use it as a data type. And then we call a constructor, we create an instance from type mini circle, okay? Or a rectangle, for example. But for an abstract class, you cannot create an instance. I just explain you why logically. Because you cannot create an object shape and you don't know what is that shape. It doesn't mean anything, right? It's meaningless. So that's what mean we having abstract class. Okay? Then, and we talked about using protected modifier on the constructor. Then we have all these methods. Those all the methods we explained during meeting 5. What is different here, inside the abstract class, you're going to have abstract method. What does that mean? You remember I told you, I show you at the beginning what we had in a meeting 5. We had a get area and a get perimeter inside the child, which is a circle or rectangle, right? But now, instead of have it within each child has it, we get it to move it to the parent and make it abstract. What does that mean? This means that I'm a parent, which is the geometrics class, and I tell you that you're supposed to have a get area method. But I'm not going to tell you what's the implementation because you're supposed to write your own. Because, for example, a circle have a different calculation to get area, صح? The same with a rectangle. You cannot create get area implementation. You said this is how you're going to create a get area, and you assume all the shapes going to have the same calculation for get area. It's logically wrong. So, super class is just tell child that you're supposed to create your own implementation for a method get area. Okay? It is not a property, it's like the main behavior. Okay, Lujan? So, the super class said one of the main behavior for you as a child to become a geometrics, to have a get area method. Then you try to write your own implementation using the override. The same with the get perimeters. So now when we back to circle, okay, I'll explain the above sentence soon. But since we are talking about get area, you see here, we say override. So the parent, the super class already have a get area. But I'm going to create my own get area, which is going to multiply your radius and then multiply by. However, a rectangle, on the other hand, if you go to rectangle, you say it's going to override a get area and it's going to implement its own get area. Because the get area the rectangle is going to be different than get area for a circle, right? Okay, so now how are we going to say a rectangle is a parent for a geometrics? We use the word extends. We already studied that in the previous lesson, right? If you would like to say this is a subclass and is going to inherit the behavior and the data from this object class, we use extend. Okay, so this is what we are doing here. It's gonna to use exactly what we learned before. Okay, forget about the rest of it. It's just an addition stuff. Okay, so if you have a super class, even if it's abstract, inside the child, you're gonna to use extend and then put a parent name. Okay, so now let's see how we can use it. The first feature, which is the importance feature for abstract class, can we create an instance from abstract class? Can we create an instance from abstract class, which is a geometrics object here? Okay, we cannot create an instance. I already wrote it before. If I write geometrics object test equal a new object is going to be wrong. But what you can do, you can use it as a type. Okay? What we can do, we can use the abstract class as a type. You see here, we use it as a type. Then we call a constructor from a child. Okay? I need you now to think with me. Now we have the geo object 1. It's from a geometric object and it's created from a circle constructor. If I would like to access the methods, if I say geo object 1 dot, let's take a look to one of the geometric methods, get a color. Can I access the get a color from an object 1 that we just created from a type geometric object with an instance circle? Can I access the get color method? Can I access super class methods? Another answer? Okay, so your answer is right. We can access it, but not it's because it's public. It's because it's public in general, but because the geo object 1, what's the type of the geo object 1? It's geometric object, right? So anything inside the geometrics object, it can be accessed because it's type, right? Not because it's public. So I can get a color. It is going to be right. So I can access a super class method. Okay. What about if I say geo object 1 and I would like to access, it is we creating a circle, right? From instance circle. And I would like to access a get radius. Can I access a get radius now? So, an object or an instance from a geometric object type, but we create a constructor from a circle. Can I access the get radius? Yes or no? More answers? Okay. Anyone has another idea or another thought? Okay, so let's try this. Okay, Bushra, that's why we tried to starting from the code and we will back explain it. So you creating, Bushra, we creating an object from a type a geometric object, which is a super class. But then we use a child constructor to make sure or to remember the geo object 1 is from type geometric object, so it can access all the geometric object methods, good? But it cannot access the circle methods. If I get to radius, we having a get to radius here. What I'm going to get? I'm going to get an error. Yes, you extended from it. If you create an object from type circle, okay, Lujan? But you create an object from super. So this object cannot see little sub. It's gonna just to use a constructor to create an object, but it's not gonna to create, it's not gonna to access its method. I know it's a little bit confusing, but Remember, you access the methods that's inside this type, the type. You don't take a look to the constructor, you take a look to the type. Okay? You get it, guys? Should I repeat it again? Or you're good? No, you don't need to write a super. Okay, Lujan. So, Lujan, we create an object called a geo object 1 with a type geometric object, not with a type circle. If I create an object circle, object 1, for example, equal new circle, and then I say object 1 dot get radius. It's fine. Why? Because the object 1, it is a type, the type of it is a circle, the data type is circle. But in a geo object 1, the data type is geometric object. You just use a circle and a triangle to access the constructor here because it's protected. You cannot use it right away. Okay? So let's complete the example. So now we're gonna to create a method. Okay, good, Lujan. So now we're gonna to create a method called equal area. It is gonna to a method under test geometric object. It's not under a geometric, it's not under a circle, it's not related to sub and super classes. It's just an object that is gonna to get two arguments. What's the type of the argument? Usually we can have, for example, integers, a string. In this type, the type is gonna to be geometric object. So the data type is geometric object for the first argument and geometric object for a second argument. We're gonna to send a geo object 1 and a geo object 2, and inside this method we're gonna to calculate the area for object 1 and the area for object 2. Here you can access the get area. Okay, so now you remember when we did the object 1, it can access, for example, a get color, right? But the G1 cannot access the get radius inside the circle. This is incorrect. Okay. Now, if I say geo object 1 dot get area, can I access that? Yes. So what is that get area? A super class has a get area, which is here, but it has no implementation at all. So when that object go and call this method, you said, okay, you have the name of the method, but you have no implementation. How I can get it? In this time, you are allowed to go to the type you are constructed and go to this get area and calculate the get area. Okay? Which is mean When we created with the type circle or triangle, you cannot access those methods directly. You can access those methods only and only if you have an abstract method inside the superclass. Okay? We can access it to superclass from any class. No, not from any superclass, from a subclass only. بالتالي you can access the abstract method from the subclass, or yes, actually it's depending on the constructor you created on, because it's public. Yes, it's depending on what's the type of the constructor you are using. Yes. Then after that, after calculating the area, we're going to create another method called display geometric object, and we're going to send the object 1, which is circle actually. And in this time, we just going to calculate the area with perimeter for it, and then we're going to do the same things for the object 2. So let's run it and see what's the output. So is the array similar? No, it's going to return false for us, and it's going to calculate the area with perimeter for a circle, with area with perimeter for a triangle, which is for a rectangle, which is the second object here. Okay, so let's back to our topic, which is the presentation, the meeting. So we stopped here. I already explained all those stuff, but we're going to say it one more time, so it is going to easily be remembered. Okay, so what is the abstract class? It's defined a common set of methods and common set of instance variable for a subclass. The abstract class should contain at least one abstract method. So we're creating an abstract class to collect common features, the common data that's going to be used by subclass. Inside the abstract class, you're going to have an abstract method. The abstract class has a common features. So what's the abstract method is going to do? It's just going to have a header. Okay, it is just going to have what? It's just going to have a header defined in a class without any implementation. I need you to remember this very clearly, okay? The abstract method doesn't have any implementation. It's look like this. Which methods we had it in our example as abstract method? Do you remember, guys? In the example we just explained, we had 2 abstract methods. What was those? Good, Bushra. Get area, and the other one you get area and get perimeters. Okay, so we had 2 abstract methods, and if you remember, we write public, abstract, and then what's the return type, the name of the method, and then we use a semicolon. We don't have any implementation. No, get color, Bushra, is not abstract method. Okay, so one cannot create. And another important concept about where is that come? Another important concept about an abstract class, cannot create an instance of an abstract class. You remember when we try to create a geometrics class equal new geometrics, we get an error. You cannot create an instance. You cannot create object from that superclass. You can use it as a type. Abstract class are specified in a class header using the keyword abstract. So you use public, abstract, and then name of the class. Yeah. الconcurrent subclass. What does the concrete subclass mean? It's the normal class they call it concrete in this meeting. So if it's not abstract, it's gonna to be concrete. Okay, concrete is the traditional one. Don't make this word feel like what is this? It's like any classes that we used to use before. So subclasses need to extend an abstract class. Even if it's concurrent, it's not an abstract class. Like the example we just saw, a circle or triangle are concrete subclass. They are not abstract, but they extend from an abstract class, which is the geometrics. A subclass should implement the abstract method using the same method header. So you see in our example, when we go to the circle and a rectangle, we implement a get area and a get perimeters. Although subclass it has it, but it has it as an abstract. So now we have to do overridden for a get area and a get perimeters inside a subclass. What about the concurrent class? The concurrent class, like when we creating any class, like geometrics in a previous example and the last meeting, when it's not an abstract, it has fully implemented classes with no abstract method. Whenever it has an abstract method, it's become abstract class. The concurrent methods, a fully implemented method. When we say it's a concurrent method, is the normal method we start to learn since 105. It's the traditional normal methods. The abstract method is just going to have a header and then you have to implement it inside the subclass. The concurrent subclass that is extended from an abstract class should implement all abstract methods. You see, we have a get area and a get perimeter inside the superclass. Then when we go to the subclass, we implement those both methods, okay? So this is again what we said in other words. So you creating an abstract method and then you have to override it inside the child subclass. You can declare a variable inside the abstract class as we saw in our examples. So it doesn't only have abstract method, it could have a variable and it could have a concurrent methods as well. But it is not possible to create object of abstract class. We said this several times. Okay. So when we need to use it, as I told you before, when it's logical, it doesn't make any sense to create an object of it. Like when you said, I just create a shape. What is that shape? I create just an object of animal. What is the type of this animal? Okay, usually when you have many classes that can have a common features, so we have a circle, rectangle, so all have the same features, area, perimeters, and then a common methods that use the same signature and implementation. Sometimes it has the same implementation, like when we use a get color, but sometimes have the same signature but a different implementation, such as the get area and it gets a perimeter. Okay, and in this case we get to create an abstract method and each child gets to create its own implementation. Okay, sorry Hamid, so what's your question? When I don't have a specification of the objects, okay, it's just as I thought it's questions. Yes, you're right, Hamid. Okay, so this is the example we saw. So we started from the example instead of starting with explanations first. So we had a superclass, we have a subclass, a circle, rectangle. We moved the get area and the get perimeter. In a previous meeting, we had it here. We moved it to superclass, but in this time, it is going to be abstract. When you when you draw with UML to specify this is an abstract method, an abstract class, the constructor is going to be protected. How you say that? You put hashtag, okay? That means it's going to be protected, and this is going to be abstract, so you cannot create an instance from it. Those are all the things that we saw. So this is a geometric, the super class. It has, those are abstract method. So you put public or whatever modifier you have, and then abstract, the type of return, the name of the methods, and then you close it by a semicolon. And sometimes it can have an argument, but in this case it doesn't. And this is the circle we call extend to the super class, and we create the circle its own implementation for a get area and a get perimeters, which is override a get area and a get perimeter in a subclass. Same with a rectangle, it's going to override a get area or get perimeter from a subclass. In some cases, the abstract class can design without the abstract method. In this case, that means you cannot create an instance of a class using the new operator. It is just going to be used to define a new subclass. This is the only use for abstract if it doesn't have any abstract method. So a subclass can be abstract even if its superclass is concurrent. For example, do you remember when we said that all classes are under, we have a class object, which is the root of all Java classes, okay? Object. Okay. Then some of the classes are concrete. Some of the classes are abstract. Like our example, when we create a geometrics object, the geometrics object is abstract class, but is already inherited from an object. As we already said that in the previous meeting, all the class are inherit from an object class. What does that mean? Again, a parent or super class is concurrent, but a subclass or child is abstract. Can we do this? Yes. Okay. So here we said a concrete methods overridden to be abstract. And this time we get to weaken a method. It was a public, for example, or it was concurrent before, which can be accessed from any methods, and then we would like to create it as an abstract. It is possible, yes. A subclass, such as a circle or a triangle, can override a method from a superclass, which is a geometrics, for example, which is not really going to happen. But usefully, when its implementation of the method in a superclass become invalid in a subclass. In this case, the superclass must be defined abstract. So, for example, in the superclass, we had a method called getColor, which is concrete method. It's not an abstract method. If you remember, getColor here, it's a concurrent. It is not an abstract. What if a subclass would like to create it, but it's make it abstract? So create, override, getColor, and create it abstract. It can possible be happen, and then it cannot access a getColor from a subclass anymore. Okay. I need you to Focus with me on this. An abstract class as a type. You remember in our example, we said the geometrics as a type, the geometrics object as a type, and then we create a new circle, a new rectangle, right? We cannot say a new geometrics object. You cannot create an instance from an abstract class. You cannot, using linear operators. But an abstract class can be used as a data type. Therefore, the following statement, which is created an array with an element of geometrics object type, is correct. So how this sentence, we say this sentence is correct. How this sentence is different than the one we created for NetBeans just a few minutes ago, when we said geometrics object, geo object 1 equal to new geometrics object, and we get an error. Do you remember, guys? How this is different? Why we can do it with an array, and we cannot do it with one object? I'll show you what I mean again. Do you remember here when we said geometrics object obj1, for example, equal to new geometrics object, we get an error. We cannot do new geometrics. But in our example here, guys, you see this is correct. Why? Okay, Bushra, Ahmed. Any other thought? Why we can do geometrics and then we assign an array, but we cannot do it in, okay, well, and we cannot do it in the previous example. If you remember, do you remember this? When I explained it in meeting 4. When you're having an array, okay, when you said circle array, new circle, this is just gonna to create an array. It's not gonna, just gonna to create an array with places from type circle. It doesn't create an object yet. To create an object, you need to put the name of the array, which is here, circle array. So this is supposed to be circle array. Okay. And this is circle array as well. Okay. So circle array, and then you define which index you would like to create an object on, and then you create an object by calling linear, and you set a type. Okay. This is, we explained this during meeting 4. So this is why this sentence is correct, because in this sentence, you don't create an object from type geometrics. You create an array that has places, references from type geometrics, and then you get to create an object in each index. This is what we do here. You do a name of the array, which is geo, and index 0, you get to create an object with a type circle. Okay. And in the second place, you're going to create an object with a type rectangle. In this time, only in this time, you're creating an object. So الgeo to call any methods from a geometrics object class. So any subclasses from under geometrics object can be called. So here first we decide to call the circle, and the second one we decide to call the rectangle. And then you can access the get area, you can access get perimeters because it's from type geometrics. But again, if you remember, I already tested this with you guys. This is exactly the same things when we test the object 1. Do you remember inside the NetBeans when I said object 1 that will get radius, it was you cannot do this. You cannot access a circle method. You can only access a method from a geometrics object because the geo is a type of geometrics object. Okay? What do you mean, Sarah? About which part you are asking for? This is what I explained minutes ago. So you can imagine a geo 0. It's exactly like a geo object 1. So you can access a get color because it's from type geometric object, but you cannot access a get radius because it's not from a type geometric object. Okay. Any question before we move to the interface? Question? Any question before we move to the interface topic? Okay, thank you. So another type which is used frequently in Java is the interface. What's the interface means and how we can use it? Again, we have some explanation here and then we have an example. I'll start with the example first and then we will back to the explanation. An interface, it's used usually when you have some methods, related methods, it's shared, it's a common methods, but you would, the same objects can have more than one interface. It's different than an abstract. Like for example, an animal here is abstract method, good? It can have a method called sound. A dog has different sound than a chicken, it has different sound than a tiger. So that's why it's abstract method. Sound here is abstract method because we need a chicken, a tiger, a dog to create their own sound. What's the sound? An interface, on the other hand, has a method called how to eat. In this time, how to eat is not related only to the animal subclass. It's not only about how to eat a chicken or tiger, not a tiger in this case, a chicken, a cow, for example, or any different animal. It can also be used from the fruit class. And this is why it's called interface. That means you can use it, different classes can use it, and in the same time, you can have more than one interface. You see chicken here, it's inherited from an animal, and in the same time, it's implemented from an interface. However, you cannot do this in a two class. Like for example, if you have another class called the bird, you cannot do an arrow to that class. This is not allowed on Java. So the same class cannot inherit, extend from two class, but it can implement from two interface. So if we have an interface called eatable, and we have another interface, for example, how to sleep or whatever interface, the same class can implement it from different interface, but not from different class. Okay, so in this example, I'll show it to you and then we will code it. We will back that to theoretical information. Okay, so we have an abstract class called animal. This is the abstract class. It has an abstract method called sound. That means inside the animal, it's not going to have any implementation. The subclass, the chicken with tiger, is going to override the sound method to make it related to them. Okay. An interface called eatable, it has one method called how to eat, and it's returns to string. And by the way, all the method inside the interface is going to be abstract, and any variable is going to be constant and final. However, the variable inside the class is not final like the interface. And not all the method inside the abstract are abstract. It can have concurrent methods and abstract method. But inside the interface, all the methods are abstract. Then we create here class called tiger, class called chicken, and class called fruit. The class of fruit is going to be implemented from an interface. To say it's going to get the information from an interface, we used the keyword implements. When it's inherits from the class or the abstract class, we use word. Which word we use to tell that subclass is inherited from superclass? Which word we're going to use? Between the classes. Extends. Thank you. However, between the interface, we're going to use implement. So let's see this code. So we're done with the geometrics. Okay. And what we're going to do now, we're going to do a test eatable. It has a test eatable has a main method, and then first we have an animal as an abstract class, and you see here it's like gray, it's not like the normal class. The animal is an abstract class. It can have a variables, okay? It can have a concrete method like a get weight in this case, and a set weight, and it can have abstract method like a sound. The abstract methods enforce a child or a subclass to create its own implementation. So what's one of the type of the animal? So the animal is a superclass. One of the subclass, for example, the chicken. The chicken extend from an animal, so it's subclass, and also it's implemented from an eatable. So let's focus first on extended animal. Inside the animal, we have abstract methods, so we have to have an implementation for that method. We have to. It's not an optional, even if it's not going to be used. The same with a tiger. You see, a tiger extends from an animal, so it's an override sound, and it has its own sound. Okay, the sound of the tiger. What still chicken has more than a tiger? A chicken extends from an animal, so it's a sub-class from an animal, and it also implements the eatable. So tiger, it's not going to be eatable in this case, so it's not going to extend the eatable. But the chicken is going to extend the eatable. So let's see what we have inside the eatable. Eatable is interface. Inside the interface, you cannot have a variable. Any variable, or if you have a variable, any variable you have is going to be final. And the only type of methods you're going to have is abstract. You cannot just create public and then it's going to return, for example, integer test 1, 3, 4. This is how we name it, and then it's not going to have any argument, and then I'm just going to have it like create just, for example, system out, print something. This is not correct inside the interface. You see, I get an error. What they said, the interface abstract method cannot be has a body. It has to be only abstract. However, if I do this, if I give this method and I put it inside the animal, which is abstract class, it's okay. You see that? This is a concurrent method. It's okay to have it inside it. Okay, so the error add a return. Yeah, I have to have a return because I put return here. So that's unrelated error to what we are explained. What I need you to remember that inside the abstract class you can have either concurrent or abstract method, but inside the interface you are allowed only to have abstract method, which doesn't have any implementation. Okay, it doesn't have any implementation inside it. But you remember here, since it's abstract, any class that's implemented, it has to have its own implementation for that abstract class. يعني احنا عندنا الآن في الeatable class اسمه how to eat. So you have to have how to eat implementation because you implemented here. Okay? And then we have fruit class, which is implemented from an eatable. It doesn't have anything inside it. We have a class orange, which is extend from the fruit. And the fruit by itself doesn't have any method, but the fruit super class. You see here how it's hierarchical is. شايفين ايش التتبع؟ يعني الآن الأورنج as a super class لما ترجع extend إلى الفروت it doesn't have anything. But the fruit is implemented from an eatable. An eatable has abstract method called how to eat. That means any method gonna to inherit, gonna to extend the fruit, it has to implement how to eat. That's why orange implements how to eat. The same thing with the apple. It's implement how to eat because it's extend the fruit, and the fruit is implement how to eat. Okay? Now, we create an array called object. We didn't create an array from type animal, fruit, geometric object. We created from object. And inside it, we have different type of object. Okay, so we have it a tiger, a chicken, and an apple. Again, remember, so if I say this is the object, which is an array, I say the object 0, I mean which one? I mean a tiger or a chicken or an apple. I say object with an index 0. I'm talking about which implementation, tiger, chicken, or an apple. Yes, tiger. So now this is tiger, but it's with which type? What's the data type? It's object. I can access, if I say dot, I can access all the method from an object type. But can I access a method from a tiger class? Yes or no? Now, this is exactly similar to what we just explained, guys. I have it from type object, and we create a constructor from class tiger. Okay, our thing is yes. Who's else? So الآن we can access a method, all the method from type object. Can we access a method from tiger? So what method do we have on side tiger? We have a sound. Let's try this. So all of you think it's yes, we can access it. What do you think now, guys? Yes, Lujane, it's no. Because it's not from type tiger, it's from a type object. And this is exactly what we explain with the geometric object, if you remember, guys. I'll just remind you one more time. Do you remember here when we created with a type geometric object, you cannot access a circle method, although you call its constructor. The same things here. It's from type object, although you call a constructor from type tiger, you cannot access its methods. Clear? Clear, or do you have any question about this point, guys? So when you're creating any object, you take a look to the data type. Don't take a look to the constructor. Based on the data type, you can decide if you can access the methods or not. So now what they need to do, they need to print out what's the type of how they eat and what's their sound. Okay. So in this loop, we're going to go over the object one by one, a tiger, a chicken, an apple. And what we would like to make sure of, first, we're going to use a method called an instance of. Do you remember? We talked this method before. What does this method do? This method is tell us if this object, so this is an object, is this object as an instance of eatable or not? So is it tiger, for example? So the first one, is it tiger object on instance 0 is instance of eatable? Yes or no? Let's back to the eatable. What does it mean at an instance of? That means it's get to implemented eatable. So where is the eatable here? Is it tiger? If we back to tiger, it's extended animal, right? It doesn't implement eatable. That's why it's not going to be an instance of eatable. However, chicken, is it an instance of eatable? We back to chicken class. So this is a chicken class. Is it an instance of eatable? Yes or no? Yes, because it's implemented eatable. What about the apple? It's an instance of eatable? Yes. If it's an instance, that means we can call how to eat method. Are you with me, guys? Okay. One important thing. So if we back to chicken, for example, we can do how to eat because it's extended eatable. But why do we put an eatable at the beginning here? What does this mean? What does this mean? When we put الأقواس هذه ونحط eatable between it, what does that mean? Yes, Awad. Good. Casting. So why we need to do casting? If you remember about the casting, if we having integer and then we having a double, you have to do casting, right? So for example, now we have an object array. So an object on index 0, we said you can access all the methods inside an object type, but you cannot access a method inside. Let's talk, we are talking about a chicken, for example. Can I say how to eat right away? No. What's the error? What we get? Cannot find simple. They don't know what does that mean. If you would like to print it out, you have to do some casting. So you have to put eatable before it. You have to castating to another class, so that the class that has this method, so you can use it. So this is what we are doing here. We castating using eatable. The same things with the animal. Objects array, the contents of this object is not an animal. So how you can back and get the methods of sound? If I would like to access a sound right away, I'm going to get an error. How I'm going to get rid of this problem? I'm going to do some castating animals. Okay. And this is the result of the code. We get a tiger sound, and then we get a chicken, how it's going to be eat. Then the chicken sound, the apple, how it's going to be eat. Okay. So let's back to our slide. Any question about the code? Okay. So now we're going to repeat what we just saw during implementing the codes, but in a theoretical way. So what's the interface and why we need it? The interface is like you construct that contains, it's like the class that contains constants and abstract method. But how it's different is going to have a list of methods that group of unrelated classes. So now if you remember in our example, we have a class animal and we have a class fruit. They are not related, but both of them implemented using an eatable. So their instance can be interact together by responding to the common set of messages. In many ways, the interface is similar to the abstract class, but how they are different? The interface intends to specify a common behavior. الهدف الأساسي للinterface is the common behaviors. Only it's going to have an abstract related. بينما if you remember the abstract class, it can have variable and it could have a concurrence methods. Okay. So example, it's what we saw. It's if it's eatable, comparable, and so on and so forth. Okay. The interface are like a class, but they only have, and this is something you need to remember. It's only have abstract methods. Do you remember when I tried to create a method called test123? Concurrence method, I cannot do it. It's going to give us error because it has to be an abstract method inside the interface, but you can do this inside the abstract class. In addition to that, the constant inside the interface, you can have constant, but it's not a variable. So it's always public static final. That means you cannot change it at all. Okay? Note that an interface is not a class and will have no instance of its own. And so it has no attributes and no constructor. So this the same as the abstract class. We cannot create an instance either from an abstract class or an interface. Okay? But the abstract class can have attributes, the interface cannot have an attribute. The abstract class can have a constructor, protected constructor. The interface cannot have constructor at all. So why we need to use the interface? Why it's useful? To have unrelated class implement similar method or behavior. مثل ما شفنا بالمثال اللي قبل شوية. That the fruits and the animal, they are not related, but they have the same behavior. Both of them are eatable. So this is the use of an interface, one of the example. The model multiple inheritance from a multiple interface. You want impose a multiple set of behavior of your class. Do you remember, I just said you cannot inherit from more than one class, strong, but you can implement from more than one interface. Okay? Some Java method can be applied in object only if implements certain interface. Sometimes you have to have implement certain interface. An interface is a special class. You can treat it as a class. Okay, but you cannot create an instance from it. We repeat this again and again using a new operator, but in most cases you can use an interface more or less same way you use the abstract class. For example, you can use an interface as a data type of variable. Do you remember when we create a geometric and then we do a new circle? So we use a geometric object as a data type. And in a second example, when we use the object as a data type, the same way you can use the interface as a data type. How we can define it? We saw it in the example, and let's say it one more time here. You put the public interface and then the name of the interface. Then you can have a constant declaration and then an abstract methods. And this is the example, which is an eatable interface that we just saw with a method called abstract how to eat. Then the methods that's going to use that interface supposed to use the word implement. So when a chicken would like to use the methods inside an eatable interface, we do chicken implements eatable. Okay? So this is the example we saw. I already explained that. And then this is the methods inside the eatable. We saw it already inside the code. One more thing. Inside the interface, if you have any constant that is going to determine that is static and final. Okay? It is going to be static and final. Any constant is static and final. Any method is going to be abstract. That means we can get rid of those. We can omitting the word static and final because we already know that any instance is going to be static and final. We can remove abstract because we know that any method inside the interface is going to be abstract. There is no way to have a concurrent method inside the interface. Okay? Now we will talk about a built-in interface. Do you remember when we talk about the class, we said that there are some classes already built in inside the Java. You find it on the Java library, such as, can you give me an example of Java library or Java classes? There's two types of classes. There is the Java classes and there is the user defined. User defined, the one that you created, اللي احنا نعملها, like a TV, like a circle, and there is some classes which is built-in classes inside the Java, such as methods, such as collection. Thank you. What else? Can you give another example of Java classes? Scanner. Good. Now we talked about an interface. In our example, we defined the user defined interface, which is called eatable, right? In our example, we defined interface called eatable. There are many interfaces are built inside the Java, such as comparable. Comparable is a built Java interfaces, okay? And it's going to come with this package. How are we going to use it and why it is useful? Because you can use it, comparable, you can use it implemented to define your own compare to method. So this interface has a method called compare to. You send type E to it, and then it is going to be called from the same types to return to compare to object or to object from the same types. Okay. Okay, so let's see this example. Do you think you can get the output? Can you guess what's the output of those sentence? And this is what I talk when I talk about you need to practice tracing, because you are not going to have a machine to test your code always. You need to practice how you do tracing. So for example, for the first sentence, when we're having a new integer 3 that compared to a new integer 5, what are we going to do? What are we going to get? So we compare to, what is going to return to us? We compare to, going to give you positive. Let me make this bigger. Okay. You see this one? Okay. So you compare to, it is going to give you. It's used to compare a current object with a specific object. So the one is going to call it is the current one, and this is the new one. Okay. What is going to return is going to get positive if the current object is greater. Is the current object is greater? No. It is smaller. So what are we going to get? We're going to get a negative. We're going to get a negative because the current object is less than the compared object. Okay. What if they are same? What if we said 5 and 5? We're going to get 0 if they are equal. Okay. So let me show you the outputs of this code. So in the first one, we're supposed to get negative because list 3 is less than 5. And the next one, C is before E, so that's why we get a minus. Then here, a date, which is a date 1, is bigger than 2013, is bigger than 2015. That's why we get positive. Let's see here. If I make it, for example, here 2013, same month, same day, what I'm going to get? 0. You're right, guys. Thank you. Okay. So this is the output of this code. So how we can use it? A comparable interface is interface allow comparing or sorting an object. We will talk about the sorting soon. Any class that implements a comparable interface must have to meet something. It's not complete sentence. The type that compression will involve in adding between this type of brackets. So هنا راح نحط الtype. We supposed to have, for example, object, integer, string, whatever. We have the compare to method. هي اللي راح تسمح لنا, which is going to allow us to define appropriate measurement of compressions compared to. So let's see this example. You can create your own comparing. So let's assume you have employees and you would like to figure it out who have higher salary. You're going to create your own compare to method. How you do this? You have the class called employee. Good. we're gonna to implement, that is gonna the interface called comparable. And inside those brackets, we send employee, which is employee, the data type. The class called employee is the data type here. How we get it to re-implement or overwrite the compare to method? We get it to compare salary from the first one and the second one, and we get it to return one if it's the first person has higher salary than the second one, and the minus if the opposite. Okay, so that means you can create your own compare to methods. Okay, and this is then how you can use it. So we having object called E1 and E2 from type with a type employee, and we send their name, their salary to compare to method, and is going to do the rest of the work to return -1 or 1 depending on the salary. Okay. So how we can use a compare to or a comparable interface? You can have your own class like a rectangle, and then you create another class, comparable class, that is going to implement interface, and then use it. Let's finish explaining the slide and I'll show you the code later. Okay. So the public class comparable rectangle, extend the rectangle, this is first, so it's going to implement the comparable, and it's going to be having a method called compare to. What is going to compare? It's going to compare an area. If the area of the current object is bigger than the new object, is going to return 1 and is going to return -1 otherwise. And if it's kilos, if they are equal, it's going to return 0. And this is override to string methods from an object, as we always see. This is talking about when you're having a class that can be multi-inheritance in Java. However, when you having inherit from the class, you can inherit only one, but with an interface you can implement from more than one. So will Java avoid the multiple inheritance problem by creating an interface. This is one of the benefits of having an interface. The class can implement more than one interface and extend only one class. Okay. So if I ask you guys about this, let's try to figure it out together, guys. If I have a class called employee and class called parent, and then we have a comparable and serializable are interfaces. Now I need you to tell me, is this declaration is correct or not? Let's see the first one. Class monthly employee, which is a new class, is going to extend an employee, the previous class, and a parent. Is this valid or not? Is this sentence is valid or not? When a class extends from 2 classes. Can we do this in Java? Why? Okay, so لجين وعوض يقولوا invalid. أحمد وبشرى. Why? Why it's invalid? So this is the first sentence. Why it's invalid? Class cannot inherit. The class can inherit يا لجين. Yes. عوض. The class can inherit only or extend from only one class. Okay? Good. Thank you all. Yes, Sarah, it's invalid. What about the next one? If I have a class called monthly employee, can it extend from an employee and implement from a parent? Is this valid or invalid? We said an employee will parent are classes, comparable with serializable are interfaces. And now we said extend the employee و implement the parent. Is this correct, valid or invalid? Are you talking, Bushra, still about statement 1? I'm talking about statement 2. So statement 2, valid or invalid? عوض لا. Both of them is classes بس مش هنا المشكلة يا عوض. So not this is the problem. Not because both of them is classes. So we extend the employee, which is a class, and then I said implements the parent. طيب يا سام, why it's invalid? We cannot implement interface. No, we implement interface. Yes, you mean classes. You corrected. Yes, that's right, Awad. We cannot implement the class. So here, the problem in this sentence, in this word, implements the parent. So we can implement the comparable, we can implement the serializable, but we cannot implement the class, right? Okay, third sentence. We have monthly employee, new class, implements comparable and serializable. Can we do this? Implement interface 1, interface 2. Is this valid or invalid? Is this valid or invalid, guys? Sentence 3. Implement interface 1, comparable, comma, interface 2. Okay, Bushra, valid. Who has another thought? Okay, Abdurrahman, valid. Another thought? Abdul Mina. Okay, Abdul Mina. Anyone that have another thought? Okay, Ahmed, valid. Okay, look then. It's valid. You're right, guys. Why? Because with the interface, you can implement more than one interface. So comparable, the first interface, and then comma, the second interface, right? What about E? Public interface sortable. We create a new interface called sortable. And that interface sortable is going to extend a comparable. Can we do this? That interface going to extend another interface. Valid or invalid? E, I'm talking about E now, guys. Are you sure, Awad? Take another look. We said interface. The interface name extends comparable. Another thought? What do you think about LE, guys? Sorry. So yes, it's valid. Why? Because the interface extends the interface in E. So that's valid. What about F? If we having an interface and then try to extend the class, the interface cannot extend the class, so this is invalid. And the last one, comparable. Now we're trying to use the comparable as a data type. We create then an object called employee1 using the new operator with the comparable, and we use it as a constructor. Is this valid or invalid? The last one. The last one, valid or invalid, and why? This one, the last one here. I already show you the answer. You remember we just said we can use an interface as a data type. So this part is correct. So if we're talking about this part is correct. You can use an interface as a data type, but an interface cannot have a constructor. So you can define a variable with an interface type, but you cannot create an object of an interface type. Okay? So that's why it's invalid. So now let's get the comparison, comparing between an interface and an abstract class. And we already saw all these information. What's happened, Warud? Anything? Any question? Let's finish this. An interface الانترفيس والabstract class, how they are different. Okay, الabstract class, it has no construction for a variable. It's going to have constructors, but you cannot use it in a new operator. And you have no restriction for a method. You can have concurrent method or abstract method. However, for the interface, a variable only static and final. It's not going to have constructor, and you cannot use the new operator. So this is similar between the class, the abstract class with interface. And in addition, the interface, all the methods is going to be abstract. Okay. How they are different, the interface is not a class. All the methods are abstract for the interface. Only constant data is allowed, only and only constant data. And an interface can be implemented by any number of unrelated class. Any number, not only one, can be implemented by any number, okay? Which is declared using implementation keyword, okay? However, in the abstract class, you use the keyword abstract before it. It has at least one abstract method. Okay. It can also have concurrent method. So not only abstract in the interface, we have only abstract method. It can also have instance variable, unlike the interface, which is only have static final. It can only contain its own concurrent subclass by requiring them to implement abstract methods. All classes share a single root, which is the object class. If you follow a hierarchical from the bottom to top, you will end with the object class as a root, okay? But if we would like to talk about the interface, there is no single root for the interface. إذا جينا تكلمنا عن classes, all the Java classes will user defined classes has only one root, which is the object class. But the interface, it doesn't have one root, okay? Similarity, both of them place a requirement in objects, and both have abstract method. Okay? Both of them, you cannot create an object from an abstract class. You cannot do new operator. And both of them, you can create reference variable, like what we did with the array, if you remember. Okay? They are normally used to refer to an object of subclass, like when we creating an object array, and then inside it we creating a tiger, an orange, an apple, and so on. Okay, both can inherit the abstract class from another class, an interface only from another interface. Okay, it can inherit. شفناها بالإكزامبل قبل شوية لما عملنا extend. يعني الانهرت الانترفيس ممكن انه هو ينهرت من الانترفيس الثاني. Good. الآن راح نتكلم بشكل سريع على نهاية وقت الكلاس. كيف ممكن ان احنا نعمل ديزاين، او كيف احنا ممكن نفكر how we can design the classes, how we think logically if we should use abstract, if we should use interface, if we should use concurrent class, and so on and so forth. Here are some rules that may help you make those decisions. بشكل عام, in general, the strong is relationships. That means you have the parent-child relationships. So we're going to use the model using a class. Like when you're having a staff member. خليني أفتح هذه. Like when you have a staff member with a person. Like sometimes you have weak is in relationships, like kind of, like the fruit, kind of the fruit, kind of the animal. And this time, this is weak relationships. It is relationships. In this way, we can use an interface. تمام? For example, all strings are comparable. So a string implements a comparable interface. You can also use an interface for single inheritance restriction. إذا أنت راح تستخدمها في أكثر من inheritance. Okay. One of the important concepts إن هي coherence. إن الأفكار راح تكون متجانسة. يعني depending on, you said, okay, I have a staff, the staff is going to be a child of a person, and so on and so forth, okay? You can use a class for students, for example, but you should not combine students and staff in the same class. يعني if we figure it out that some class, they're going to work as a sibling. We can call them, they can work as a sibling, like the student will staff. They are not going to have all the information. The ID اللي حق students is going to be different than the ID اللي حق staff. The staff, for example, is going to have a salary. Students have the course registration. So they are not going to be in a parent-child relationships. ما راح تكون العلاقة فيهم parent to child. They're going to be a sibling, for example, and then the parents could be a person, a parent or a subclass. Okay. Another thing, sometimes it's good to separating a responsibility مثل ما شفنا قبل شوية بالstudent والstaff. لما يكون فيها so many responsibility or unrelated responsibilities, it's good to separate them. One of the example الكلاس اللي حق string. الكلاس اللي حق string عندنا فيها class string في string builder و string buffer. String builder و string buffer it's almost similar. They have a little difference في synchronization. يعني كل كم راح يغير القيمة. السترينج بفر أبطأ لكن السترينج بيلدر more efficient. السترينج بفر إنه هو يخليك يتأكد إن المعلومات سيف إنه هو ما راح يعمل override على معلومة جديدة. This is not important things to talk about. It's not related here. But the main point that we need to say, there is some difference between them. That's why we have it in a different class. Okay? Designing the class are designed for reuse. الفكرة الأساسية من we using a class because we would like to use this class again and again. Okay, so it's important not to make it so specific. It is good to have it general. Okay, so it's important to understand إيش هو الorder, the environments that we are working on. To design a right class, okay? So to define what and when the user can do it, okay? The attribute, which is going to be in a data field, can set probability, the probabilities اللي حق الclass, design a method to function independent of their order. ما راح يعتمد على الأوردر methods. مهم, it's important to have at least one constructor, and it's good to have no argument constructor. يعني احنا تعلمنا ان في constructor we can have no argument, one argument, two arguments. It's always good to have no argument constructor in addition to other constructor. It is good to override the equal with two string اللي جايين. هذه ال equals with two string are a methods coming from an object, but it has its own implementation. It's good to create the right implementation depending on our need. Okay. Follow the standard Java naming. ما نستخدم الأسماء تكون محجوزة. For example, always place a data declaration before the constructor and place the constructor before the methods. الترتيب راح يساعد ان الشخص ممكن انه هو يقرأ الكود easily for him or herself again or for someone else. So you start with the data, constructor, and then the methods. Okay. Also provide the constructor and initialize the variable to avoid the programming error. إذا كان في قيم, some variable are important. It's always good to initialize it as at the beginning, okay? To make sure that you don't get an error later, okay? And the last slide, one of the things, okay, now if we're almost done, this is the last slide. So we're using visible modifier. المodifier حنا تكلمنا عنها بالميتينجز السابقة. You need to use it right. So it's either public, private, default, protected, depending on the need. You need to define a modifier. Each class can present two contracts, one of the user and one of the class. Okay. Make the feed private إذا أنت ما تبغى أحد يعمل لها access, and you can make the method protected if you don't need the classes from other package, for example, access it. Like what we saw in the constructor, the abstract class method. The contract of the extension, okay, extended class may be increase the visibility of the instance method from protected to public. We already talked about it in a previous. So السب class مسموح له انه هو يرفع الفيزيبيليتي يخليها اكثر وضوح. فهي ممكن تكون في السوبر protected، يجي السب يعملها public. But you cannot do the opposite. You cannot tweak the visibility. So if a super have it public, a sub cannot come and make it protected, for example. Okay? We already explained this in a previous meetings. Okay? The class use the private modifier إذا أنت حاب تعمل hiding إلى الداتا. It cannot be accessed from the other. You can use the get method, the set method to provide the user with the access to the private data. So if you're having any private data, you make sure that you have the appropriate setter والgetter حق كل private area اللي موجودين inside the class. A class should also hide the method not intended for the client use. So if there is any method that are not supposed to be accessed by the clients, we can make it protected or private. Okay. So sometimes we need, for example, to have a counter. We need to know number of students. That's it is not going to be related to one object. So حنا لو عملنا public integer, for example, counter, كل object is going to have its own. But what if we would like to have a counter that counts a number of objects? In this time, we need to use the static. Okay? So if you're having a static counter, whenever you would like to count how many objects you have to create a static variable. Because other variables get to be related to each object, and you cannot count the number of objects then. Okay, so this is the end of our meeting. I know it's quite lot of information, so you need to get back to it and practice it by yourself. Any question? لجان meeting meeting 6 هو meeting 7 بس GCC عمل الأسماء كذا هي ما في meeting 6 meeting 7 هي meeting 6 I know it's a lot of information guys أنا عارفة أن هي معلومات كثير وعارفة أن هي تنعطى online. It's quite challenges بالنسبة لكم وبالنسبة لي حقيقة يعني كأني أشرح الأشباح. Sometimes you answer me, sometimes no one is here. أعتقد مثل ما تفضل أحد الطلاب أنه ممكن على أساس الطلاب عندهم اختبار. بس أنتوا شفتوا الآن بالكويز. I really worry about you guys, and it's important to follow the meeting one by one. Don't leave it until the end. So حاولوا أنكم تطبقوا. مهم أنكم تمسكوا الأكواد تحاولوا تحلوها by yourself. And if you have any question, I'm always there. لو أي طالب عنده سؤال, you can always email me. I'll be more than happy to answer you guys. I'll try to discuss مسألة الوقت. راح أرجع أناقشها مرة ثانية مع الBCT. أنا عارفة أنا already تكلمت بهذا الموضوع للي دخلوا